In a furniture workshop, a worker steadies a vertical stack of wooden panels. When another sheet is added, the balance slowly changes and control starts to slip. Never rely on the human body as a stabilizing method for vertically stacked materials. In a transport yard, a worker stands on a flatbed trailer preparing a large steel coil for offloading. As a restraining band is released, the coil begins to shift. This scenario illustrates the behavior of stored mechanical tension. Steel coils retain internal stress due to forming and compression processes. When restraining bands are removed, that stored energy may express itself through expansion or rotational adjustment. Never position your body directly in line with a restraint during release. Use extended tools to increase separation distance and reduce exposure. Before removing any band, ensure the load is properly blocked, chalked, or supported by approved handling equipment. In a warehouse, a worker climbs onto stacked cardboard boxes on a forklift. As his weight transfers, the boxes compress and begin to shift. Never use loose cargo as an access platform. Cardboard boxes are designed for product containment, not load-bearing or lateral stability. When subjected to human movement, they deform independently and lack a mechanical connection, resulting in inconsistent support characteristics. Use approved access equipment such as stepladders, order pickers, or mobile work platforms designed specifically for elevation. Reduce pallet height to a reachable level before handling individual items. Inside a steel factory, a high-temperature process vessel operates outside normal pressure and temperature limits, increasing risk to nearby personnel. Industrial vessels operating at elevated temperatures are subject to combined mechanical, thermal, and chemical stresses. Over time, lining wear, corrosion, or component degradation can reduce system safety margins. If protective devices or control systems do not respond as designed, internal conditions may move beyond intended operating limits, resulting in a non-standard process state. Establish and enforce calculated exclusion zones around active thermal process equipment. Pressure relief devices must be inspected, tested, and verified on a defined schedule. In a maintenance yard, workers inspect a dump truck with the bed raised overhead. During the inspection, the bed begins to move. Never position yourself beneath a raised dump bed without verified mechanical support. Hydraulic systems are not positive locking devices. They depend on seals, fittings, and pressure integrity. Any loss of pressure can allow unintended movement. Always engage the manufacturer's safety prop or use certified blocking devices rated for the load. Lower the bed onto the support so the weight is carried by solid contact rather than hydraulic pressure. Confirm stability before entering the work area. If proper support is unavailable or compromised, suspend the task until the condition is corrected. In an industrial yard, a forklift loses stability while transporting a heavy steel cylinder, prompting an unsafe response from the operator. This scenario highlights the difference between human reaction capability and machine physics. Forklifts operate within defined center of gravity limits. Once those limits are exceeded, motion is governed by gravitational forces rather than operator input. Leaving the operator position removes the protection provided by the machine's structure. Follow manufacturer guidance for stability events. In many cases, remaining seated, holding the steering wheel, bracing, and leaning away from the direction of movement provides the greatest level of protection. Equipment damage can be repaired. Human injury cannot. Avoid entering the machine's movement path during instability conditions. On a city sidewalk, a painter works from an elevated mobile scaffold. As a co-worker begins to move it, the base moves and the platform becomes unstable. Never move a scaffold while it is occupied. Mobile scaffolds are tall, narrow systems that depend on base stability. Introducing horizontal movement generates lateral forces, and even minor surface irregularities can exceed the scaffold's designed stability margins. Workers must descend before repositioning the scaffold, lock casters before climbing, verify surface conditions, and use outriggers when required. Treat short repositioning movements with the same level of control as longer relocations, as elevation amplifies small changes. Inside a deep construction trench, a crew guides a concrete pump hose during placement. As attention stays on the pour, the boom overhead starts to shift. Concrete booms combine structural, mass, pressurized hydraulics, and moving material. Any reduction in holding capacity, pin retention, or hydraulic stability can result in unintended repositioning. Restricted work areas limit available movement space and increase exposure potential. Limit time spent beneath boom structures. Inspect pins, retainers, hoses, and joints before operation. Position personnel laterally where possible and pre-identify clear movement paths. Plan concrete placement to minimize overhead exposure duration. In this glass warehouse, large glass sheets rest on an A-frame rack without mechanical restraint. As the balance point shifts, the load transitions forward under gravitational influence. Never rely on manual contact to stabilize vertical loads. Large glass sheets possess significant mass and smooth surfaces that provide limited friction. Without mechanical restraint, stability cannot be maintained once balance conditions change. Use retainer bars, locking rails, or approved strapping systems. Whenever vertical sheets are stored, employ vacuum lifters or mechanical clamps during handling. Ensure the rack, not the worker, provides primary load control. In a cement factory, maintenance work is underway near a ball mill access hatch. Due to incomplete isolation, the mill starts turning. Maintenance performed without complete energy. Isolation represents a lockout/tagout breakdown. Ball mills retain substantial rotational inertia. If isolation is incomplete, automated systems or control commands may re-energize the equipment. Apply personal locks at the primary isolation point. Use tags and permits, verify isolation through a dead start test, and confirm zero movement before entering maintenance zones. Every worker must maintain direct control of their own lock. On a factory floor, a worker enters the guarded area of an injection molding machine to clear a stuck part. While attention remains on the task, the machine cycle initiates and platen movement resumes. Injection. Molding machines rely on interlocks to prevent motion during access. If interlocks are bypassed, misaligned, or malfunctioning, movement may occur despite an open guard. Mold areas are designated restricted zones due to high closing forces. Verify guard function at the start of every shift. For internal clearing tasks, stop the machine and apply full lockout/tagout procedures. Treat internal access as a machine entry operation requiring verified zero energy and complete control isolation. On top of a large thermal processing system, a maintenance worker conducts an inspection. Shortly thereafter, the machinery initiates movement. Thermal process environments involve multiple energy sources operating simultaneously. If any automated sequence or control command can initiate movement, the system is not in a verified maintenance-safe state. Apply personal energy isolation before elevated or internal access. Verify zero energy. Implement mechanical and electrical isolation and enforce permit controls.